This is the third fancy graph problem that we've had. So on this one, I'm not going to do it for you. I want you to try it on your own. I am going to give you some hints along the way though. So let's talk through it for a moment. And this is 2018, and this is problem number 3. This is more of a classic fancy graph problem where they have it at the top, and let's go ahead and read through it. So it says graph of g. So this is a graph of g, obviously, and the graph of the continuous function g, they're saying continuous, which means we can take derivatives, possibly we can integrate, all that kind of stuff. We also have access to theorems and things. The derivative of the function f is shown above. The function g is piecewise linear, right? So piecewise linear from there to 3, and then all of a sudden it becomes a parabola from 3 all the way to 6. Okay, so it looks like all the information is about g, and then of course the first question that they're going to give us is going to be about f, which is a little bit confusing, right? Because they're asking us about f, and then how is f related to g, right? It tells us that g is the derivative of f. So this is a derivative, right? G is the derivative. So in other words, if I had f and I took the derivative of it, it would be g. Or another way to say that would be if I integrated g, then I would end up getting f. Okay? All right, so this is the derivative. So right now they're giving me an initial condition, and what they want me to do is go from 1 and go backwards all the way to 5. Right? And I'm talking about f, so what we're going to have to do is we're going to have to find, we're going to have to integrate from 1 to -5. So we're going to have to find all of that area and all of this area with the initial condition that we're starting with 3 in the first place. Since we are going backwards though, this is going to be negative area or negative value, and that's going to be positive value or positive area because we are going backwards, which is the opposite of forwards. All right, so anyways, like I said, you're doing 2 things. You have 3, and then you have to go ahead and add on whatever this value is right here. Okay? All right, next one. B, it says evaluate, and this just says integrate from 1 to 6. Integrate this thing from 1 all the way to 6, which is right there. And it looks like to do that, this part will be pretty easy to find that value, right? Find that value should be easy. That's going to be 4, and then we're going to have to add on, let me get the highlighter again, add on this area right here, which they gave us the equation for. The equation is right here, right? So you're going to still have to integrate from, and it looks like this starts at 3, and it goes all the way to 6, g of x, which is that equation. So you're going to have to integrate that equation. So what I wrote down was 4, which was the area of the first section from 1 to 3, and then you have to actually, and I guess I should put a dx right there to make it official, but integrate this portion. And that's going to be worth points, so make sure you write that down and then actually integrate to get a value. Okay? All right, C. From, and you can tell I got a little bit of water there. I was just washing my hands. You know, you can never be too safe. But from -5 to 6, on what open interval, if any, is the graph of f both increasing and concave up? Okay, so once again, the question is about f, and we're going to use the derivative to answer that question. So what that means, if it's increasing, that means when I look at g, g has to be, g is the slope, right? G is the slope of f because g is the derivative. So if f is increasing, g, let's say the value of g is positive. So basically looking at the graph, where is the graph positive? Looks like it's positive up here. And then the other part of it that they want is concave up, and concave up occurs when we have a second derivative that is positive. Right? This is already the first derivative, so we really want to take the derivative of this thing, which means the slope of the derivative. So for concave up, I'm going to write the slope of g has to be positive. And so we're looking for, where is the slope positive? Positive, positive. And then this section right there, all the way to 6, is positive. Okay? So you will have to describe it, and I've basically given you the answer for the description, a reason for why you're saying it, but you have to say what x values both have the value increasing and also have concave up for f. All right? And last part. Find the x-coordinate of each point of inflection on the graph f. And once again, we don't have an actual picture of f, so we're using the properties of g to help us with f, and it says give a reason for your answer. So if I'm looking for a point of inflection, that definition would be point of inflections occur when the second derivative is equal to 0 or undefined, with a sign change. So it has to go from either positive to negative or negative to positive. All right? So since we don't have the second derivative, we have the first derivative. I'm going to change this. Instead of it saying second derivative, I'm going to say the slope of the first derivative. So basically, you're going to look at this graph and you're going to figure out when is the slope, because this is the first derivative, 0. When is the slope 0? When is it undefined? And it also has to have that sign change. So this might be something kind of goofy because the slope right here is 0, but is it going from a positive to a negative or going from a negative to a positive? And once again, we are just listing the x part. All you have to do is just say what x values and give this is the reason for your answer. You just have to figure out the x values, okay? All right, I also, at the bottom of my site somewhere, I will have a link to all the answers for all these problems. I found a nice website that has answer keys. So you can check your answers afterwards, and good luck.